Hi, we are from Group 17. We consist of 4 members, which is me, Betty Hoyutlay, Muhammad FIKRI bin MUHILI, FATIN ATIRAH binti Muhammad ASRI, and Nik Muhammad AIZAT bin Jafar. Today, we will present on Experiment 3, which is the modeling of transmission line. This presentation will cover on the introduction, methods, results, discussion, and lastly, the conclusion. As an introduction, a transmission line is a system of conductors that transfers electrical signals from one place to another. And to design a transmission line, we need to concern on 3 aspects, which is the efficiency, line losses, and also the voltage drop. After we design the transmission line, we can measure its performance by calculating the value of the percentage of voltage regulation, the voltage and power of sending end, and also the efficiency. There are 3 types of transmission line in this experiment, which is the short, medium, and also the long transmission line. To conduct this experiment, we are using 2 methods, which is the manual calculation and also the MATLAB program. This is to compare the values between 2 of it, and some of the values in the manual calculation are used in the MATLAB program as well. This is the flowchart for the manual calculation on short transmission line and also the medium transmission line. As you can see, both of these flowchart are quite similar because we are looking for the same value, which is the voltage regulation, the efficiency, the sending end power. So firstly, for the short transmission line, we need to find the impedance, the receiving end voltage, the apparent power, current per phase, the sending end voltage, and also its magnitude. And then we can use the equation given to find the values that we want. And next, for the medium transmission line, first we need to find the inductance, capacitance, and also the resistance. And then we use it to find the impedance, admittance, and also the ABC constant. After we find all this value, we can find the current per phase and also calculate for the receiving end voltage per phase. For the ending voltage, also we can find, and then we can use the equations that are provided to find for the values that we need. Next is the MATLAB program. This one is for the short transmission line and this one is for the medium transmission line. To start off, we open MATLAB and then use a new editor page for each of the program. And then the steps are quite similar. Firstly, we define the value and then we enter the command for the equations. And then we can enter the command to display the questions. And finally, after we are done with the programs, we can just click run to simulate the program and then our output will appear. This is the last program for this experiment, which is for the Y-bus matrix. Similarly to the previous flowchart, first we define the value and then we enter the command for each of the inputs. And for this one, we are using for loop to display the matrix. After that, we use a command to display the bus matrix. And then when we are done, we just click on run to simulate the program and then our output of matrix will appear. That's all from methods. Now I will pass to the next member.
Assalamualaikum and hi to everyone. My name is Muhammad Fikri bin Muhili and my metric number is DE190037. And today I'm going to show you the simulation for our lab 3 power. And here, first of all, we start with the short transmission line. And as we can see here, this is my coding already input inside the MATLAB software. And I run the simulation. As we can see here, this is our value that we get from the program. And for my 0.8 power factor lagging, my voltage regulation value is 1.3645 and my efficiency is 94.4252. Furthermore, for my 0.8 power factor leading is my voltage regulation is negative 4.4144 and the efficiency is 94.4252. That's all for the short transmission. Next, for the medium transmission line, and here I already put my coding also, and I run the simulation for this program. As we can see here, at the command window is need us to state the value. I will state the value first. After I already put my value here, and the program already automatically calculate as a coding that I put. And here for the voltage regulation value is I get 20347852.816339, and the efficiency for this medium transmission line is 0.000116. So that's all for the medium transmission. Okay, next for our final exercise, which is exercise 2, it needs us to put the coding for the Y bus in the metric form. So here we can see the the coding or the program that I already put, and I run the simulation. Also, it's the same with the medium transmission line. It needs us to put the value first, and then it will calculate for us. Okay. Okay, as we can see here, I already input the value for this program, and here is the Y bus for the admittance in matrix form. So that's all from me. Thank you.
Hi, Assalamualaikum. My name is FATIN ATIRAH binti Muhammad ASRI. My metric number is DE190050. So today I will continue the presentation today with the discussion part. Electrical power is transmitted from a generating substation to numerous distribution units through a transmission line. It delivers a voltage and current wave from one end to the others. Transmission line that is less than 500 km long is referred as a small transmission line. Minimal leakage of current. The transmission line capacitance is ignored, and the other components such as resistance, inductance are grouped together to form a transmission line series impedance Z. So that's all from me. I will pass to the next presenter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad AIZAT bin Jafar, and my number metric is CE200044. So I want to talk about conclusion for our group. So for the conclusion is the system designer and other interested parties can use this model to gain a basic grasp of transmission line behavior impact and first pass analysis, as well as appreciate the relevance of not only the component and circuit design that make up a PCB, but also the routing. For the conclusion number 3 is constant RLs and C are uniformly distributed along the length of a transmission line. And the last but not least, the conclusion is the series impedance is made up of resistance and inductance. And thank you for your time, and this all for our group 17.